In this video, we're going to continue talking about measures of spread, in particular approximating the standard deviation with grouped data. We've already spoken about calculating standard deviation if we have the raw data. But recall, there are times that we are not given the raw data to look at and we're just given a frequency distribution. So we're going to talk about how we can calculate the standard deviation for these frequency distributions or grouped data. So the first thing to do is to compute the midpoint of each class. And when we're talking about the midpoint, recall that that is x sub m. So x sub m just means the midpoint, and we calculate that by taking the lower class limit plus the lower class limit of the next class and dividing it by 2. After we compute the midpoint, we need to compute the mean. Recall, for a sample, we computed the mean by taking the midpoint times the frequency, adding that up, and dividing by n, our total frequency. Same situation would happen with the population. We would just change it from x bar to mu. After we've computed the mean, we're going to subtract the mean from each class midpoint for each class. So that means we're going to take the midpoint and subtract the mean from it. This is our deviation that we discussed for regular standard deviation. Then we're going to square the difference, just like we have before. We're going to take that midpoint minus the mean, and we're going to square it. After we have squared it, we're going to multiply that by the frequency for each class. So we're going to have one of these values for each class. We will add up all of those products. So that's the midpoint minus the mean squared times the frequency. Add up all those products. Once we've added up all those products, we also need to make sure that we have the same frequency in total frequency, which we've already used once computing the mean. Then we're going to divide by that sum. Depends on whether we're looking at population variance or sample variance. Remember, if it's a population, we divide by n, the total frequency. If it's the sample variance, we divide by n minus 1. Since we're looking at standard deviation, we want to take the square root of that variance. So let's look at an example of this and calculate the standard deviation for a frequency distribution. We'll go back to our example regarding miles run per week. And these are the miles run during 1 week for a sample of 20 runners. It gives us the classes and the frequency. So we're going to set up a table similar to what we did when we're finding the mean, because we're going to have to compute the mean again here as well. And so if I set up a table that looks like this, I have a column that has class, a column that has midpoint, which we still need to calculate, a column with frequency. Then I'm going to take the midpoint times the frequency. The sum of that divided by the total frequency will give me my mean. After I've found the mean, I'm going to take the midpoint, which is over here, minus the mean. I'll take those values, square them, and multiply them by the frequency. Then I will take the total of this column and divide it by, in this case, since we're talking about a sample, we're going to divide it by n minus 1. So let's start out by finding the midpoint for each class. The first class, to find its midpoint, I take 6 plus 11, which is the lower limit plus the lower limit of the next class, and divide by 2, and I get 8.5. I continue that process down, getting 13.5, 18.5, 23.5, 28.5, 33.5, and 38.5. And remember, all I did was, such as for this midpoint, I took 21 plus 26 and divided by 2. Now, I'm going to take the midpoint, this column, and multiply it by the frequency. And so I'm going to take 8.5 times 1, and that will give me 8.5. 13.5 times 2 will give me 27. 18.5 times 3 will give me 55.5. 23.5 times 5 will give me a 117.5. 28.5 times 4 will give me a 114. 33.5 times 3 will give me a 100.5. 38.5 times 2 will give me 77. To compute the mean, and we're talking about the sample mean, I need to find the total of this column and the total of this column. So I'm going to have 8.5 plus 27 plus 55.5 plus 17.5 plus 114 plus 100.5 plus 77, and that total is going to be 500. And I have a total of 20 runners. So my mean is going to be 500 divided by 20, and that is going to give me a mean of 25. I will continue to compute the midpoint minus the mean. So I'm going to take 8.5 and subtract 25 from it, which will give me a negative 16.5. I'm going to continue that with the 13.5 minus 25, and that will give me a negative 11.5. 18.5 minus 25 gives me a negative 6.5, not 16, negative 6.5. 23.5 minus 25 is going to give me a negative 1.5. 28.5 minus 25 will give me a 3.5. 33.5 minus 25 will give me an 8.5. 38.5 minus 25 will give me 13.5. Now I'm going to square this value and then multiply it by its frequency. So I'm going to take negative 16.5, square it, and then multiply it by 1. And that's going to give me 272.25. Notice I'm not doing any rounding in this column. I don't want to do any rounding, period, until my very, very last step whenever I'm computing these things. So a negative 11.5 times 2 is going to give me 264.5. Negative 6.5 squared times 3 will give me 126.75. A negative 1.5 squared times 5 will give me an 11.25. 3.5 squared times 4 will give me a 49. 8.5 squared times 3 will give me a 216.75. And 13.5 squared times 2 will give me 364.5. So now I have all my columns filled in. and I want to find out what the sample standard deviation is. Remember that that is S, which is equal to the square root of S squared, the variance. So in order to find the variance, I need to take the sum of this column, which if I add each one of these up, I should get 1,305. Stop the video at any time and check the math, see if you're getting the same thing. So I'm going to take 1,305, and I'm going to divide, since this is a sample, I'm going to take 20 minus 1. And I'll eventually take the square root of that. So that's going to be 1,305 divided by 19, taking the square root of that. This is again where we want to leave it in our calculator because we do not want to do any rounding. So we're going to do a couple of things. Depends on how you want to do it. You can go ahead and put in the square root symbol, which is that second x squared button. Or you can calculate this and then take the square root of it. Either way, if you calculate what's inside first, you'll get 68.6842 with some other numbers. Again, do not use just this number. Use entirely what is available to you. Leave it in your calculator. Do not do any rounding. You take the square root of that, and you're going to get, let's see, just to be on the safe side, if I take 1305 divided by 19, take the square root of it, I get 8.287593772. Okay, our classes are whole numbers, which indicates that our raw data would be whole numbers as well. So since everything is whole numbers, we're going to round this to 1 decimal place. Now notice that the 8 is larger than 5, so I'm actually going to get that the standard deviation is 8.3 because I need to bump this 2 up to a 3 based on that 8. Try some of these standard deviations and variances of grouped data, and let me know if you have any questions.